Philips Medical Systems has prepared a set of safety videos for education and training purposes. Apart from a short MRI introduction video, there are 3 separate safety video modules, which address RF safety aspects, magnetic field safety aspects, gradient magnetic field safety aspects. The information in this presentation applies to all MR systems, but the effects discussed are more relevant for MR systems with stronger gradient systems. Apart from the powerful static magnetic field and the RF field, each MR system applies switched gradient magnetic fields to define the position of structures within the human body. Unlike the static magnetic field, the RF and gradient fields are only active during scanning. However, in common with the static magnetic field and the RF field, the gradient magnetic field system requires certain safety precautions. This presentation begins with a short introduction of the system creating the dynamic gradient magnetic field. The next section describes the potential hazards of the gradient magnetic field and the way in which they can be prevented, followed by the consideration of possible contraindications. Finally, the presentation concludes with a summary and a list of the appropriate safety precautions. Gradient magnetic field introduction. Every MR system includes a carefully designed set of gradient coils. The gradient coils create the switched gradient magnetic fields needed to determine the location of the RF signal emitted by the protons in the human body. The gradient fields are applied in 3 orthogonal planes, the X, Y, Z planes, and are switched on and off only during scanning. The strength of the gradients is determined by the amplitude of the gradient magnetic field, measured in Tesla per meter, and by the switching time in seconds. It is therefore expressed in units of Tesla per meter per second, the slew rate of the gradient system. Higher amplitudes and shorter switching times result in a higher slew rate of the gradient magnetic field. The 3 independent gradient coils generate the gradient magnetic fields for each of the 3 orthogonal directions and are created by copper leads carefully positioned on the coil housing. The stray field of the gradient magnetic field outside the magnet bore is much smaller than that of the main magnet, but may not be neglected. Potential hazards. Although the switched gradient magnetic field is much weaker than the static magnetic field, the rapid changes in gradient field strength present 2 different effects that may result in a hazardous situation. These are acoustic noise and nerve stimulation. The acoustic noise results from mechanical forces on the gradient copper leads. These forces, known as Lorentz forces, are due to high electric currents applied through the copper leads, which lie within the static field of the main magnet. Since the copper leads are not free to move, the sudden application of force results in the typical knocking sound of the system. This sound becomes louder with higher currents, shorter switching times, and a higher static magnetic field. The amount of acoustic noise generated can approach the maximum noise level allowed, requiring appropriate precautions. The acoustic noise generated by the system is not only relevant for the patient, but can also affect the operator or other personnel present in the examination room during scanning. The nerve stimulation results from the electromagnetic fields generated in the human body by the switched electric currents in the copper leads of the gradient coil. This effect is observed in the kilohertz frequency range as opposed to the RF system, which produces electromagnetic fields in the megahertz range and results in heating of the human tissue. mild form of peripheral nerve stimulation can be accepted. This nerve stimulation effect is generally only relevant for the patient. As a result of the stray field, the effect may become relevant for medical personnel, such as an interventionalist who approaches the patient during scanning. Preventing potential hazards. For acoustic noise, exposure to a higher level than 140 dB peak noise is never allowed to prevent permanent damage to hearing. Temporary hearing damage can occur at lower noise levels. International MR safety standards for patients allow a maximum sound level of 99 dB for up to 1 hour. To keep the exposure below this level, some hearing protection in the form of earplugs or a headset is necessary and obligatory for almost all MR systems. Earplugs are not always effective for all patients. Positioning of the plugs in the ear is a tedious job. Headsets can also be applied incorrectly, and in the case of children and babies, this can become a practical problem. Peripheral nerve stimulation can become painful or even intolerable at the stronger gradients of modern MR systems. Therefore, International MR Safety Standard specifies limits for the allowed gradient output. From the literature, it is known that the threshold level for cardiac nerve stimulation is about a factor of 10 higher than that for peripheral nerve stimulation. Consequently, the occurrence of peripheral nerve stimulation provides a good warning and protection level for preventing cardiac stimulation. Peripheral nerve stimulation is first observed as a slight contraction of the skin. This can vary considerably in position over the body and is very subjective. There is no known long-term health effect related to the nerve stimulation. The gradient output level of every MR system is automatically limited to values of the mean threshold level for patients. However, since this threshold level is very subjective, sensitive patients may feel some peripheral nerve stimulation during routine scanning. Contraindications. Since all patients can usually be provided with hearing protection, there are no patients for whom an MR examination is contraindicated in view of the acoustic noise production. Extra care must be given to sedated patients because they cannot indicate that the hearing protection is not applied correctly. Similarly, extra care is needed for young children and babies. There is still an ongoing debate about scanning pregnant patients and potential hearing damage for the fetus. So far, there have been no reports of negative effects of the acoustic noise of MR systems on the fetus. There is no specific class of patients for which an MR examination is contraindicated because of the possible occurrence of peripheral nerve stimulation. Because peripheral nerve stimulation could come as a surprise for the patient, patients should be properly informed of this possibility to avoid restlessness during scanning. Philips MR scanners have 3 levels for the gradient output, related to the mean threshold level for peripheral nerve stimulation in patients. Below 60% of the mean threshold level, low, no peripheral nerve stimulation is to be expected. Up to 80%, moderate, peripheral nerve stimulation may occur. From 80% up to 100%, high, peripheral nerve stimulation is more likely to occur, and in very exceptional cases can even be painful. Scanning at levels above 100% of the mean threshold level is not possible. Summary. The gradient magnetic fields in modern MR systems are becoming increasingly stronger. This may result in more acoustic noise produced by the scanner and also increases the possibility of peripheral nerve stimulation. To avoid harm to the patient, the following precautions must always be taken. particularly for MR systems with strong gradient systems and high static magnetic fields. Always apply hearing protection for the patient. Take extra care to avoid hearing damage when scanning sedated patients or young children. All personnel present in the examination room during scanning should wear hearing protection. The patient must be properly informed about the possibility of peripheral nerve stimulation. Medical personnel close to the patient should be aware that they may experience a mild form of peripheral nerve stimulation during scanning. This video highlights some of the basic guidelines for safe operation of an MR system. It does not give a comprehensive list of all possible hazards. In addition to this, you must read and understand the chapter on safety in the instructions for use of the MR system. If issues are not clear, please contact your local physicist or application specialist. Provided that the appropriate safety precautions are observed, MRI is an inherently safe modality providing images of outstanding clinical value.